Unit 6. Before the break, we finished up Unit 5. Unit 4 and 5 were both over quadratics, okay? And square root functions kind of go hand in hand with quadratics, okay? You're going to see some similarities. First, we're going to start with the graphs and key features, and we're going to talk about review transformation rules. But a lot of this stuff, like transformation rules, these transformation rules don't change from function to function. It doesn't matter if it's a quadratic or an absolute value or a square root function. The transformation rules, what A, H, and K do to the graph, are always the same. Okay, so we're going to be reviewing these things. It's the same things they did last semester. We're just starting with a new parent function. Okay, so our parent function is the square root function. So what that looks like is, get a pen up here. All right, so the function is just y equals the square root of x. Now, anytime that you need help coming up with a graph, if you don't know what a graph is supposed to look like, you don't remember the shape of the graph or the location, you can always use Desmos. So you could go and type this into Desmos and look at the graph and get some points and plot them and have it, okay? Or anytime you're unsure what a graph should look like, you can always make an XY table, an input output. X is your input, Y is your output. So you can just pick some values to input or test and see what the output is. So I'm going to start in the middle here. I'm just going to say 0. If I'm to input a 0 for X, what is the square root of 0? 0. Okay, so there's a point at 0, 0. What if I input a 1? What's the square root of 1? 1. So there's a point at 1, 1. Now, I am not going to input a 2 because I know the square root of 2 is going to be a decimal. I don't know it off the top of my head, and I'd rather not plot points at decimals. So what is the next perfect square after 1? What's the next integer that we can take the square root of and get an integer output? 4. What is the square root of 4? The square root of 4 is 2. Oh, my pen stopped working on me. There we go. So there's a point at 4, 2. Okay, we could do one more. What's the next perfect square? 16 is a perfect square, but it's not the next one because the square root of 16 is 4. What would we be skipping over here for our outputs? Right now we've got 0, 1, 2. What's next? 3. What is 3 squared? 9. 9 is the perfect square. So the square root of 9 is 3. That's the last one that's going to fit on this grid, so I'll stop there. Now, notice I only went from 0 into the positive inputs. If I try to input a negative, can you take the square root of a negative? Is that a real number? No, that's when we got those imaginary numbers last unit, okay? Last semester, we talked about complex numbers, imaginary numbers, okay? We can't take the square root of a negative. That is an undefined value that is not going to show up on the graph. So I'm just going to graph the curve through these, okay? And that is my parent square root function. Okay, the HK value that they're asking for over here. Okay, HK is referring down here to our transformation rules. Okay, remember what's being added or subtracted inside is your H, what's being added or subtracted outside is your K. Okay, and it starts out as a minus H and a plus K. Okay, so if it is in the parent function, is there anything added or subtracted outside or inside that radical? Nothing, right? So they're both zeros. Okay, so our HK is actually here just 0, 0 to start with for the parent function. Okay, it's this end point right here. Okay, so HK is the end point. So I'm going to highlight. Well, that's not what I wanted to do. Okay, hang on. There we go. So HK is the end point. I'm going to write that down here as well. Okay, it is just your HK value. Go ahead and write that. Okay, so H and K determined the endpoint. All right, now, for the parent function, that endpoint is at the origin, 0, 0. So what is your x-intercept and y-intercept? Where does this graph cross the x-axis? Yeah, at 0, 0. Where does it cross the y-axis? At 0, 0. If your graph goes through the origin, that is both an x and a y-intercept. If you write 0, 0 as one of them, you better write it as the other. Because if you're going through 0, 0, you're going through both axes. All right, now domain and range. Remember, domain are our x's and range is our y's. So it's always least to greatest. So domain, the x-axis goes left to right here. Okay, so it is least to greatest, so left to right. So how far left does this graph go? 0. How far right does it go? Yeah, that arrow there at the end, it would keep going. We could keep inputting any positive number here and get an output. So it's 0 to infinity. Interval notation, remember we use parentheses, we just do least, comma, greatest, and then we use parentheses or brackets. A parenthesis if it's not included, a bracket if it is included. 0 is included in the graph. There's a point at 0. And parenthesis for infinity, because you can never equal infinity. You'll never reach it. So we use parentheses. That's interval notation. Now remember, you also need to know inequality notation. So inequality notation, you would have your variable x or y, in this case x, because we're talking domain, and it would be between the lowest and the highest, so between 0 and infinity. But when it goes to infinity in one direction, you can actually just write your inequality. X is everything to the right of 0, isn't it? Okay, to the right is greater than. So we can just write this as x is greater than or equal to 0, because it's everything from 0 on to the right. Now the range is your y values. How low does this graph go? What's the lowest value? 0. What's the highest? It's going to be infinity as well. As this graph goes to the right, it's going up. So it's going up forever as well. So our range in interval notation is exactly the same as the domain. A bracket on the 0, a parenthesis on the infinity. But then for the inequality notation, we do need to change that to a y instead of an x. So it's y is greater than or equal to 0. It's everything above 0 or equal to 0. Now you're increasing and decreasing intervals. Okay, if you need to make side notes, you can make side notes to refresh your memory. We read a graph. Yeah, go ahead. We read a graph just like we read a book, read a sentence from left to right. So when I look at this graph, like trace it from left to right, is it increasing or decreasing? From left to right, am I going up or down? Yeah, it's going up. Increasing and decreasing is talking about is the y value going up or down? Okay, our y value is going up, but it's as x goes from left to right. So as x increases, what is y doing? That's what this is asking. So as we go from left to right, our y value is going up. So this is increasing, and we list it in x values. So from left, that is 0, and it's going up forever, so to infinity. So it actually matches our domain in this case, but increasing and decreasing intervals, they're talking about the behavior of the graph. You never use brackets for these. So this is just going to be parentheses. Does this graph ever turn and change direction and start decreasing? No, so there's no decreasing interval on this one. You can write none. You can write it with the circle with the line through it like I did. And make little side notes in the margins if you need to about do not use brackets for these. This is the behavior of the graph from left to right. Okay, anything that you need to remember about how we answer these, you can make side notes in the margins over here. Okay, so that's the parent function, and these are the key features. Now we're going to refresh on our transformation rules. So remember, A, H, and K are the three values that we've learned about for transformation. So we've got, okay, let's start with our A value in front. Okay, our A value is going to tell us the direction of the graph, if it's opening up or if it's been reflected. Okay, so in the parent function up here, what's A? What's multiplied in front of this square root? Oh, understood 1. There's nothing there, so it's like multiplying by a 1. It doesn't change anything. So in the parent function, A is 1. So when A is something other than 1, that's when we have a transformation based on A. If it is negative, okay, if A is negative, the graph is going to do what? It's going to flip or reflect over the x-axis. If you need a visual of that, instead of starting at the origin and going up, it would come down this way. It would be decreasing. Okay, it would be flipped upside down. Okay, so if there's a negative, that's what happens. Now, what if it's some number other than 1? Okay, so if it's greater than 1 or if it's less than 1, that tells us whether or not it is a vertical stretch, if it's greater than 1, bless you, or a vertical compression, if it's less than 1. Now, the way this is notated, this is saying the absolute value of A, because we're not worried about the sign. The sign just tells us if it's reflected. If there is no negative, then it's not reflected. But the actual number, the absolute value of A, okay, if it's greater than 1, it's a stretch. If it's less than 1, it's compression. Okay. Then H and K are what tell us, first of all, where the end point is, but that also, if the end point is moved away from the center, that's shifting the graph. These are a shift. So here you can see in the parent function, there's nothing added or subtracted. We said it was at 0, 0. So there was no shifting in the parent function. This is where it starts. Okay, now if there is an H or a K value, that is going to shift our graph. Okay, so H is going to shift our graph horizontally, left or right. Okay, so this is going to be the horizontal shift. You need to make a note. Horizontal is this way, left and right. Okay, now in the equation, there is a negative, a minus. It's x minus h. So if that h value itself is positive, it's going to appear to be negative in the equation. It's going to be x minus 2, for instance. H is actually a 2, but if you see x minus h, that means it's actually going to shift to the right. Okay, so if you see x minus h, that's shifting right. If you see x plus h, that means h is actually negative and it's going to shift left. Now your K value is what's added or subtracted on the outside, and it is our vertical shift. Vertical is up and down. Okay, so if that K, and it's a plus in the equation, so if it's plus, that means it actually is positive and it's going to go up. If it's minus, it actually is a negative and it's going to go down. So we've talked about the parent function and we reviewed our transformation rules. So let's try to apply that. We're comparing these equations down here to the parent function, and we want just to describe the transformation that's taken place. So I'm going to go through and highlight here. We're going to focus on one at a time. Let's look at A. So in number 1, what is your A value? Yeah, there's nothing there. It's an understood 1. So A is 1. That means there's no stretch, there's no compression, and there's no reflection. So nothing so far. What is A in number 2? Yeah, your A is 4, which means what? Good. So if your A is greater than 1, you have a vertical stretch. Okay, and this by 4 in this case. Okay, what about in number 3? What is your A? Yeah, you see that negative there in front. There's no number, so it's just a 1, but negative 1. Okay, what does that tell you about this function? Very good. So this one is going to reflect or flip over the x-axis. So we know it's going to be upside down. Okay, and what is A in number 4? One over 2, 1/2. What does that do? Very good. It's less than 1, so it's a vertical compression. Awesome. All right, so we've got down A. Now let's look at H. Okay, so our H value is inside the radical. So here I see x minus h. So what is your h value? My h value is actually positive 7. Very good. So that means that this is shifted to the right 7. When you see x minus a number, it's actually to the right. What about in number 2? Is there anything added or subtracted inside that radical? No, that minus 1 is not under the radical, it's outside. So h here is just an understood 0. There is no left or right shift. What about in number 3? What's your h value? Okay, I see x plus 3, so h is actually negative 3. So this is going to shift left 3. And in number 4, what is h? Good. The positive 2, which means this is to the right 2. All right, last but not least is our K value. Remember, our K is what's added or subtracted on the outside here. Okay, and so let's identify those. So here that was a positive 2, so that is up 2. here. That is a -1, so this is down 1. There's nothing I highlighted in number 3 because there's nothing outside that radical being added or subtracted. So your K is an understood 0, so this graph does not shift up or down, okay? It stays where it is vertically. And then your K here is a -6, which means down 6. You'll feel okay about describing those transformations? Okay, good. All right, then this next one shouldn't be too bad. It's working in reverse. Okay, these were giving us the equation, asking us to describe the transformation. Okay, now they give us a description and ask us to write. So we're just going backward. Okay, so I'm still going to identify my A, H, and K. It says the square root parent function is reflected across the x-axis, shifted 7 units left and down 1. Okay, so up and down, that's K. And it is down 1, so K is -1. It says it's reflected across the x-axis. What does that tell us? What do we know about A if this is reflected? Negative. Now, does it say anything about a stretch or a compression? So it's a 1. So just -1. And then it is shifted 7 units left. That would be H. Now to the left means H is -7. But remember, when I go to plug this in, we have A and the square root of x minus H plus K. So when we plug these values in, A is -1, K is -7, or I'm sorry, H is -7, K is -1. Okay, so when I look at this, when I simplify, I don't need the 1 there, I can just have the negative. Now, what happens when you have minus a negative here? Yeah, so that's going to be x plus 7 under the radical. And then plus -1, I'm just going to write as -1. So that would be my equation given that information. So the negative reflects it, the plus 7 shifts it left 7, and the -1 shifts it down 1. Okay, are y'all understanding? Can y'all understand the difference of what you're adding and subtracting when we say inside versus outside, whether it's under that radical symbol or not? So some of those that only have one or the other, you have to be real careful. That is underneath, so it's H. This is not underneath, so it's K. So be careful with those. All right, go ahead and flip that over. On the back, we're going to take a look at graphing and identifying key features. We did this on the front with the parent function. Okay, this is just now taking into account transformations. Can you still identify key features? You should be able to graph this by hand. Do you have to be able to graph it by hand? No. What tool do you have at your disposal? Desmos. You're welcome to use Desmos. Just type this in and you can see the graph and then answer these questions. Okay, but really we should know based on AH and K how to graph this. What has happened to the parent function graph? What does this +5 on the outside do? It shifts it up 5. So really, we should be able to just go here, look at this parent function that we started with, and shift all these points up 5, and that's our graph. Because that's the only transformation here, is up 5. Nothing else is happening to it. Okay, you can identify your A, H, and K off to the side if that's helpful to you. You can see your A is an understood 1. Your H is a 0. There's nothing inside added or subtracted. And your K is a 5. So again, this is up 5 if you want to describe the transformation. So my HK is 0, 5. That's my endpoint that I'm going to start with, which is just the endpoint of the parent function shifted up 5. And then you can make a table, you can plug in other numbers, or you can just do the movements from the parent function. Over 1, up 1. Over 4, up 2. Oops. Or over 9, up 3. From that endpoint. And that's the same graph as the parent function, just shifted up 5. Now you can also get this in Desmos if that's easier for you. Now, Desmos will surely give you this graph, and you can click here and see what points are, or you can make it give you a table, but it doesn't define these words for you. You do have to know the vocabulary and what this is asking for and be able to write these, okay? What is the x-intercept here? Where does this graph ever cross the x-axis? It doesn't. There is no x-intercept now because that graph is shifted up off the x-axis. Okay, what about a y-intercept? Does it cross the y-axis? At 0, 5, yeah, at the endpoint. Okay, so what is the domain here? How far left to right does this graph go? What is the leftmost x value? 0. And the rightmost? Infinity, right? That arrow means it's going to go to infinity. So the domain did not change from the parent function. You could still write it as x is everything greater than or equal to 0. The range has changed because the range is low to high, and the low point of this graph is different because the graph is shifted up. What's the low point now? 5. And it goes up forever. So it's 5 to infinity for the range, or you can write that as y is everything greater than or equal to 5. Is this graph still increasing when I look at it from left to right? Yeah, and it never turns. So it's still an increasing graph from what x value to what x value. Where does it start? At what x value? 0. The x is 0. So from left to right is 0 to infinity. So from 0 to infinity, this graph is increasing. So that didn't change from the parent function either. Okay, if the domain changes, then yeah, your increasing or decreasing interval is going to change. We feel okay about that? So that was just the parent function shifted up 5, and we were able to still give the key features. Okay, one last one. Now this one's got some more transformations. What's A here? Good, it's -1. Okay, what is H? And K? Very good. So my HK is 2, 3. That's my starting point or end point, whichever way you prefer to think of that. So 2, 3. Now, to get my additional points, I can take all of the parent function points and shift them. This went right 2, up 3. However, I don't just shift them right 2 and up 3. I also have to do what? Because A is negative. Yeah, I also have to reflect it. So instead of from this endpoint, instead of going over 1, up 1, I'm going to go over 1, down 1. And instead of over 4, up 2, I'm going to go down 2. 7, 8, 9 would be here. 1, 2, 3, that would be here on the axis. So if I extended this, okay, I could get that point there. I can sketch that curve. So now I've got this opening upside down, which it should be because A is negative. What is the x-intercept? I just plotted it. Let's see, where did that end up being? 11, 0. If you don't know it, graphing by hand, that's fine. Go to Desmos and click on it. It will tell you where that location is. What's the y-intercept this time? This graph doesn't cross the y-axis, so no y-intercept. Okay, domain. How far left does this graph go? What is the leftmost x value? Is the x value at that endpoint? 2. And how far right does it go? 2 to infinity. You could write that as x is greater than or equal to 2. Okay, now range is low to high because this one is flipped upside down. It's not going to be k to infinity. It's going to be negative infinity up to k. And what is that k value? It's 3, right? So as an inequality, instead of saying y is greater than or equal to 3, it's below. So it's less than or equal to 3. Now this time, is the graph increasing or decreasing when I look at it from left to right? It's decreasing and it never changes. So there's no increasing interval this time. It is decreasing from what x value to what x value? Good. Same as the domain, 2 to infinity. But it's always parentheses for increasing and decreasing intervals. All right. So that's transformation rules and key features for square root. You have the parent function to reference. Okay, you get to use Desmos. Take advantage, use Desmos. You have got a Delta Math assignment here, your first assignment of the new year, of the new quarter, of the new semester. Let's make it new year, new you, and stay on top of your assignments. Don't fall behind. Let's not get zeros and late work and missing work. Okay. This assignment is relatively short. You know, when we create these, it gives me an estimate. It averages how long students take to do these types of problems and tells me the average amount of time that it should take to do this assignment. And it's like 12 minutes. So it is not an overly long assignment. This is just some practice to make sure you've got the hang of what we just covered. Because you just watching me is not going to prepare you to do it on a test. You have to practice doing it yourself. Okay, so make sure that you're doing the practice. What you don't finish in class today, sometime finish it up. You could do that in CatTracks. You're going straight to CatTracks from here. And remember, you could sign up for my CatTracks anytime this week, or you can work on this at home or in the mornings, evenings, whatever. Okay, but this is due Thursday by 11:59 p.m. New year, let's start with 100s across the board. Okay, remember, it's just a completion. Get 3 right from this section and this section and 4 right from this section. You can do it. Okay, you can ask each other questions, use those notes. If you're still stuck, ask me questions.